Okay, so hello everyone, thanks for joining. I'm going to do a quick introduction here and then hand it over to Sonatus. My name is Paul Boys. I'm the Community Director for COVESA. If you're not familiar with COVESA, COVESA is an open, collaborative, and impactful technology alliance accelerating the full potential of connected vehicles. We're going to talk about VSS today. The VSS is the Vehicle Signal Specification. If you don't know what it is, it's a common approach for describing vehicle data. It is a data model for vehicle. And data, of course, is the backbone of the connected vehicle in and out of the vehicle. So today we have our first in our COVESA Spotlight sessions, where organizations from the COVESA community present their use/implementation of COVESA's Vehicle Signal Specification. And they will answer the following questions: why VSS was used, what was the value of using VSS, how VSS was used, and what could be improved in VSS. So today we have Sonatus. Sonatus delivers technology and solutions that accelerate the vehicle's software innovation. They're going to present using COVESA Vehicle Specification to accelerate next generation vehicle services. With that, I'm going to hand it over to Sonatus and let them take it. Go ahead, John.
Hello, everyone. I'm John Heinlein. I'm the Chief Marketing Officer from Sonatus, and we're here based in Sunnyvale, California. Joining me is our CTO and co-founder, Fang.
Hello.
And we have Sudhir, Director of, give me your title so I don't get it wrong.
Yeah, Director of Cloud Software.
Fantastic. And we're thrilled to talk to you about a little bit about our products and especially about how we're using VSS to accelerate our products and to help, we think, provide better common framework. So I want to start with just a brief introduction to Sonatus. We're based in Silicon Valley, based in Sunnyvale, California, and we're delivering today production software into cars. So a lot of buzz around software-defined vehicle today and lots of discussion of what that means, and we'll talk about that in a minute. But we're not doing this in theoretical fashion. We have cars on the road, and by the end of this year, probably reaching 1 million cars on the road with our technology in it, especially from our partner Hyundai and their affiliate brands Kia and Genesis. We are winning awards all over the place from our technology, from PACE Awards to Autotech and others, where we're delivering a number of different innovations that are going to help cars be more effective, more efficient, better data capture, and other kinds of value that we'll talk about a little bit today. We're based in Sunnyvale, but we have offices around the world, particularly in a lot of auto centers in Europe and in Asia. And one of the things we believe in, and we've got a strong background and a pedigree of experts from the data center world, from companies like Cisco, Juniper, and many others like that, where we're bringing data center experience to the cars. And a lot of people say, and we really believe that cars are becoming a data center on wheels. So we're trying to bring the same kinds of data center infrastructure into the cars, things like security, things like strong networking, configurability, strong connection to the cloud, and so on. And so a lot of the work we're doing here and the work on key standards follows on the heels of that kind of experience in data center, where you've got to have standards because things have to interoperate, things have to be effective and work together. And we believe those kind of things are going to help vehicle technology accelerate. So with that in mind, we're going to hand off to our CTO to talk a little bit about our vision of software-defined vehicles, and it'll lead into the discussion of VSS and how we use it.
All right, thanks a lot, John. All right, so I think SDV is a very hot topic these days. I think there are probably a lot of different opinions about what it is, but fundamentally, it really just means that the user experience of a vehicle as a product is fundamentally defined by the software that's running in and out of the vehicle these days, right? So by having this software, it helps improve the functionality of the vehicle as a product in many different ways, from infotainment to ADAS, which helps you driving, to battery management system, and so on and so forth. Right. It also means that the vehicle as a product is no longer a static product. After a user purchases the product, they can continue to experience new functionalities, new capabilities, and even new services from this product. Right. So it continues being upgraded, as well as provides extensibility after development, right, after SOP. It also means that for OEMs, they can save a lot of cost during their development if they adopt the right practice, right, during their development. And it also enables OEMs to create new business models beyond just selling vehicles as a product, but offering all kinds of services, both to their direct customers as well as to their partners. And that means much more ways for OEMs to be able to monetize and also serve their customers and partners much better than before. And of course, it also brings much faster time to market capabilities to the OEM, allowing them to bring basically new user experience much faster than that was possible before. Okay. But there are also some key challenges that OEMs as well as the whole ecosystem that will be facing when trying to realize this software-defined vehicle vision, right? So we just maybe highlight a few of them here. The first one is data volume. So we know that the software capability is fundamentally defined by the data that those software are able to access, right? And the data is continuously growing, especially in modern vehicles, right? And it's still growing because there's more and more sophisticated sensors as well as new subsystems being introduced into the vehicles, right? So the amount of data that's coming from the vehicle is huge, right? So therefore, but those data are very important, right, for all kinds of applications as well as services, right? And a lot of time, those applications and services needs to be supported by cloud infrastructure and runs in the cloud, right? So therefore, a lot of those vehicle data has to be sent from the vehicle to the cloud. But it's impractical to send all those data to the cloud all the time, right? Because of the limitation of cost and bandwidth. Okay? So this is one particular challenge, right? The second part is that I mentioned earlier that software-defined vehicle allows OEMs to bring continuous improvements, right, and capabilities to their users after SOP. However, today the main mechanism to deliver that kind of upgrades and new experience is through OTA, right? But we know that OTA has its limitations. A lot of time it's quite heavy. It takes a long time to deploy, and the whole user experience is not smooth. It also incurs quite a bit of cost to the OEM, right? Not to mention the time it takes to prepare, test, and deploy the OTAs. So therefore, it is really important to figure out ways that OEM can make those updates happen more quickly, right? So this will really help them to enable new use case, new business opportunities, and satisfy evolving customer needs, right? And also sometimes just urgent bugs that happen that they have to address very quickly, right? To be able to do all that in a timely fashion, right? So this is the second challenge. The third challenge is that not only the volume of the data is growing, the variety of the data is also growing today, right? And also we know that the ways that those data are being used are also growing. So one of the inhibiting factor now that's kind of hindering the development of the use of those data is the inconsistent naming. So this happens at all levels, right? This is happening from ECU to ECU, from bus to bus, and from models to model, and from region to different region, and of course from OEM to OEM, right? So this is a significant issue that's creating barriers for OEMs as well as their partners and vendors like us to try to create new applications based on those variety of data, right? And it's not only naming. A lot of time it's also like the units that are used, right, to represent those are inconsistent, and sometimes they're just flat out conflicting with each other, right? We've seen some example of that. And also it can create a lot of confusion because the same name sometimes can mean different things depending on which ECU you're talking about or even which model you're talking about. So this is definitely becoming a much bigger problem. Now we are moving towards a software-defined vehicle. All right, with that, I will hand it over to John to talk about some key technology solutions that we're offering OEM to help them in their journey to accelerate software innovation.
Thanks. And so what we wanted to show you are two examples today of some of the products and solutions that we're delivering, and we showed some of these recently at CES a few weeks ago, but also as a way to kind of motivate the importance of VSS and how we're using it. So the first is our vehicle data collector product. And this is production technology in production today, rolling down the road. You can see it driving past you on the highway, where OEMs are able to collect fine-grained configurable data from vehicles. And what's powerful about this, and it addresses some of the challenges that you mentioned in the previous slide, is today there's lots of data in the car, but on any given time, in any given moment, tons of it is probably not applicable to adding value. You want to identify what are the data points that are necessary for different situations at different times, and that might vary. Similarly, you might like to be able to gather fine-grained data, for example, for diagnostics. Imagine you've got a situation where there's some sort of vehicle dynamics issue, which is the vehicle's acting funny in some situations. Well, to gather that data, typically speaking, in a normal situation, you'd have to deploy a custom OTA that would say, gather this data, and that data would be set up to the cloud in bulk, massive streams of data going up to the cloud, much of it not showing the problem. So one of the things our solution allows you to do is create custom trigger conditions that allows you to identify exact situations in which you believe the situation's happening and to collect fine-grained data in those regimes. This allows you to get much finer-grained data than will be possible if you send it continuously, but only in the regions that matter. And you'll see that in a demonstration in just a minute. What's also great about this is we've got our software, this data collector software, deployed in vehicles from Hyundai and their sister brands already. And by having that in there, it allows us to do lightweight, quick policy updates. It doesn't require heavyweight OTA. It doesn't require gigabytes of data down to the car. Actually, it can be sent in kilobytes. We like to joke that it's the size of a tweet, which is actually pretty close to the size of a tweet, to send policy updates to the car to gather different data. Also allows you to, of course, stream to clouds, do data analytics, however it makes sense to you. We also see there's a lot of downstream benefits from this, whether it's preventing recalls, whether it's enabling new monetization, even OEMs better understanding their cars, understanding how the car is being used in a fine-grained way better than they are today. We find in talking to our OEM customers that they repeatedly tell us that despite them, owning the car, making the car, the nature of the way data comes back from the car today is they often don't understand how the car is being used as much as you might think they do. And so this is an example of a product that we believe can help address those kinds of problems. Now, fundamental to data collector is data. And so the issue is, how do we describe what data we want to capture? How do we describe the signals to get? And when you have a fleet that might be a heterogeneous fleet, even within a single OEM, how do you make sure that that recipe can be deployed across a heterogeneous fleet? And that's where VSS can come into play. So I wanted to quickly show you a quick demonstration. And this is something we showed at the Consumer Electronics Show a few weeks ago. This is our data collector running. And if you can see in the upper right corner, this is a live stream. This was a car driving live. This is recorded now, okay? But this was running live, and the car was driving around our office in Sunnyvale. And down here on the map, you can see where it was driving live. And on the left, you're seeing a number of different data sources streaming live from the vehicle in Sunnyvale to our booth in Las Vegas. And I'll direct your attention to the nomenclature here. You're seeing VSS signal names across all of these plots. And then there's others here which actually have VSS signals being active, but we didn't show it on the GUI, but they're also VSS signals as well. And what you're seeing is a number of different important things going on here. First, you're seeing variable data granularity. If you'll notice here on just the speed to make it easy to see is in the background, we had a background recipe showing every 2 seconds, we would show, hey, what's the speed of the vehicle just for background monitoring. But then this particular example was showing driver braking behavior. So looking at fine-grained driver braking behavior, and anytime the driver presses on the brake, which you can see here with brake pedal position, now we started gathering data at 100 millisecond granularity of brake pedal position, the acceleration, the braking force, and so on, as well as gathering, for example, fine-grained data about vehicle speed. So if we were trying to do analytics, for example, of some sort of braking problem, by getting this fine-grained data, but only during the regions that are important. We can balance the upload data storage costs, while at the same time getting the data needed to diagnose the issue at hand. And so VSS was important for us here, and our GUI allows us to select the data shown here using VSS, and it was really important. I want to show you a second example of another one of our products, which is the Vehicle Automation Manager. And we showed this also at CES, although I'm not going to show a demo today. This takes the idea of data collection, which I just showed you a minute ago, and takes it to the next level to add automation. So instead of just capturing data and sending the data back, which is super valuable, here we're also taking the data and then causing actions. Those actions could be within the vehicle, for example, having the vehicle play sounds or play alerts or change its behavior in some respects. Or it could also send actions outside the vehicle, say, for example, sending proactive notifications or communicating to the headquarters or so on. And eventually you can imagine the same kind of capability could do things like V2V or V2I. So what's nice about this, similar to the VDC solution I showed a minute ago, is in a similar way, we can deploy these kinds of automations and these kinds of automation recipes, we call them, in seconds. In a similar lightweight payload, we're able to define these actions to the vehicle. And we showed an example where, imagine you're an OEM and your competitor comes out with a feature and all this, your vehicle's already shipped. We showed how it would be simple to create a recipe in only a few seconds and deploy to vehicles in near real time to allow your vehicle to change the behavior and reflect the behavior that perhaps your competitor has deployed. So it's excellent for prototyping. We find it can be helpful for diagnostics in both manufacturer as well as potentially post-shipment diagnostics, and potentially unlocks things like new monetization models. Obviously, here again, VSS signal naming is critical because not only are we going to be capturing data like we showed in the previous example, but we may want to then take actions as well. And by providing that consistency, particularly if you want to deploy this across a heterogeneous fleet, it's crucial to have VSS, and we're really pleased to be working with this. At this point, I'm going to throw it to Sudhir to talk about a little bit more details, and then we can get into some questions and answers.
Thanks, John. Thank you everyone for joining. So as John, you, Fang talked about, the challenges with SDV and the solutions that the Sonatus provide in order to help OEMs to overcome those challenges. We want to definitely highlight the benefits of COVESA VSS, which has helped us on this journey, and our OEMs and our partners. First of the benefit is the interoperability, which is a very, very huge benefit because we definitely want consistency across different models, across different vehicles, infrastructure, and OEMs. This is going to enable basically the faster innovation. That is the second benefit, because all that data that is being collected from the vehicles and the automation that we are trying to add to the vehicle, we have to make it easier for the application developers in order to be able to utilize that data for different purposes. It could be predictive maintenance, it could be data monetization aspects, it could be for empowering usage-based insurance kind of use cases. And if an application developer has to basically adopt its application based on a model, brand, and they have to continue to change, then it slows down the innovation. And that's where VSS comes in to help the OEMs in order to solve that challenge, because the app developers can write a common app which could work across brands. It also hides a lot of details about the low-level architecture, which is important because a lot of application developers are not like R&D vehicle infrastructure designers who are not very closer to the namings of the signals. So having an abstraction layer is super important, because then they do not have to worry about what is the speed called in a particular model. They just focus on vehicle speed being the VSS naming convention. The naming convention gives very clear meaning because of adoption of VSS, because now you can know that speed is going to be speed no matter what model brand is being used, defined, how it is defined at the lower level. It also highlights reduced cost as a benefit, because now you can reuse your code, so your development costs are lower. Your software is reused across different brands, models, and it's easier for a programmer to ramp up, because we have hidden all the details and it's a high level interface that they need to interact with. Also, another benefit is the easier aftermarket usage. Now, all the data that OEMs and their partners end up collecting from the vehicle, of course, satisfying the GDPR and other regulations, it helps them provide a consistent view to the downstream consumers who definitely build apps and develop the ecosystem around the vehicle infrastructure. And it lowers their burden because now they can reutilize their applications in order to enable more use cases. And that's an important aspect as well, because data is useless if you cannot use it.
Let me dovetail on that point a second. So you talked earlier about abstracting the low-level architecture. One of the benefits of our solutions, the data capture, the vehicle data collector, and automation solution we've provided, is because they don't require coding, and because they don't require coding validation and heavyweight OT updates. It's possible, and in fact, it's a benefit of these solutions to be able to provide access to them to a range of different people. You could have test engineers who are quite involved in the details and software developers, but you could also have people in the OEM, for example, who want to do understanding of how the vehicle is being used. Which of my features are being used and how frequently for future vehicle planning decisions, for example. Well, that might be something you want to expose to a product manager or a vehicle planner. And one of the benefits of our solution is we provide access control so that they would only be able to access signals that are relevant and can't cause any problems. But to do that, they're not going to understand the low-level EE architecture. They're not going to understand the weeds level things. So by providing this abstraction away and knowing that they're going to get consistent data and the data that they think they're reading, it's going to be super valuable. So this aftermarket usage is important. It could be aftermarket within the OEM or even potentially downstream value-added solutions that could be built on top of this infrastructure that the OEM provides. So especially important to abstract that away.
Yep, definitely. Thank you, John. And the last aspect we want to touch on is the safety. Vehicles are our driving force. VSS does help in those regards as well, because consistent use of signals avoid naming conventions, avoid confusion across the application developers, even the ADAS algorithm developers. If they can utilize the consistent naming and the units, is important because it changes from region to region. You want to make sure you're taking the right actions based on how you're reflecting that value. If it's kilometers per hour or miles per hour, and if they understand the clear nuances and the clear indication of what the unit is, they can adopt their application accordingly. You can easily share the data for a vehicle to vehicle kind of use cases using VSS, because now you have different vehicle models and brands which can communicate with each other and share this data, and that could reduce and solve different other kind of use cases in order to maybe even reduce traffic on the roads and make it roads a little bit more safer, because one vehicle braking can send this information back to the other vehicles which may be piling up, and they can slow down their speed. And if the consistent naming convention is used there, it makes it easier for utilizing the data. So there are a lot of benefits. We have highlighted a few of the important key benefits of VSS, and definitely we have seen a great benefit of adopting it ourselves and having our OEMs and partners move in that direction to solve the challenges of SDV.
Yeah, maybe let me add a little bit to that. Just for the engineer audience out there, just to go down maybe a little bit deeper level here, because when you are actually working on the softwares in and out of the vehicle, right? Really, there are two ways the data are being used and important, right? The first is as a way of communication or information exchange between different applications, right? So in that sense, they need to speak some common language here. If there's no common language, we always talk about like APIs, right? We focus a lot of time on the APIs, but what we have not focused is actually the data that's going between them, and creating a common understanding of what those data means across different applications, right? With proliferation of all kinds of applications, both in and out of vehicle, this is becoming even more important now, right? So that's one. So this is information exchange across applications. The second is the data is increasingly being used for data analytics, right? To derive insights from the data. So that means you need to have consistent ways of understanding what those data are, right? And then you have to label, a lot of times you have to label the data, right? Because you may want to train your AI model and so on and so forth. But if you don't even have a consistent naming of the data, it just makes it much harder to be able to label your data, right? It creates much more burden and slow you down, right? So in terms of those two very practical things, in terms of software development, I think having a very consistent naming for all the different type of data is very, very important.
What's been your experience in a pre-VSS world? Or your experience with the kind of the signal naming conventions, and how easy is it to deal with in a pre-VSS world? Maybe I wonder if you can speak to that.
To our experience, it's pretty hard because we have seen a lot of different formats being defined, and every time you launch a new model, the application developers who are building the applications, they have to adapt to it. They have to understand and keep up with the ever-changing vehicle architecture, which makes it harder for them to keep up with the new vehicle model rollouts because they are happening quite often. So it definitely is a lot of burden where there is no code reusage and they don't feel confident. It slows them down in building and focusing on new innovative applications rather than supporting the previous generation use cases that they have built. So I think we have seen definitely pre-VSS, there were a lot of challenges around it.
Yeah, but also I think John, Sudhir, and myself, we work in some other verticals before, right? But for automotive vertical, I think this is actually especially a important problem to be solved because there's some unique things here in this industry. Because one is when you're creating the vehicle, which is the ultimate product, you actually have so many different components coming from so many different vendors that has to be put together and have to work seamlessly together, right? So it's not like you have a single company that creates everything by yourself, okay? So that's one. And two is after you build the vehicle, still, if you want to create different services to help your, say, for example, rental car company customers, to help your insurance partners, and so on and so forth, right? So that means you have to create services and applications across a fleet of vehicles that may encompass many different models, right? And also, if you want to help fleet managers, then a lot of times they have vehicles even coming from different OEMs. So how can you make those services and application be possible, right? Which requires very consistent, data naming across, all this scopes.
Absolutely, and I think I was also going to observe that this isn't a theoretical problem. I mean, we have the privilege of working with our OEM customers across a number of different models, many different models, and even within a single OEM customer, because of the point you made, a minute ago, that there are many different blocks, and from generation to generation, you may see different hardware, or even different tier one suppliers, perhaps, that are integrating different subsystems. Our experience has been that even within an OEM, there's significant difference from model to model, but you think, oh, that's a theoretical problem. In practice, it's okay. But actually, in practice, it's quite different, even model to model,
Yep.
which means these problems can be real problems. Am I right about that?
Yes,
Sudhir?
absolutely right. Yeah.
Fantastic. Well, I think at this point, we'd love to open the floor for questions if people would love to chime in. If not, we'll keep talking. We could probably talk for an hour and a half about this, but I kind of want to open the floor if someone else would like to jump in, or Paul, if you want to help facilitate questions, that's happy to have you.
Yeah, so I think people should just speak up and ask, and we'll see how it goes from there. Otherwise, if you want to raise your hand, I'm happy. That'll work too. So if you have a question, please ask it.
Okay, I think there's a question here.
Is there a question in the chat?
I see a small window.
Let's see. The question is, excellent presentation. Thanks for sharing. One question: does the Sonatus solution abstract the signals and adopt a consistent taxonomy to the signals in the vehicle or in the cloud? So that's a good question. Do you want to take that, Sudhir?
Yeah, so there are multiple benefits, and you can definitely, VSS allows you to define at multiple different places in the vehicle on the cloud side. The initial starting point that we have taken is starting on the cloud side because it helps you support the legacy vehicles, which would be harder to adopt and change the code and OTA to adopt the VSS on the vehicle side. So on the cloud side, we have started the journey, and definitely, that's where we have started the journey, and we'll continue to add the journey on the rest of the ecosystem.
And just to build on that, for people who don't understand the way our solution works, By doing that, we provide a cloud-based management console for all the solutions we provided, and the cloud can allow you to deploy these configuration recipes and policies we've discussed. So by providing the signal mapping in the cloud, we've then effectively abstracted all that model difference and OEM difference. So even though the cars themselves have the differences underlying, it's hidden from the user, and the user doesn't have to experience that.
Correct.
And the cloud provides that abstraction, which is why we made that choice.
Yes. Yes.
Do you want to add anything to that, or is that?
Yes. So so actually, ideally, right, you want this to be a consistent naming to be applied from the very beginning of your design process, ideally, right? And have every piece of data that gets generated in your vehicle to have a consistent naming from the very beginning, ideally, right? But the reality is much harder than that, right? You have a mixture of components coming from many different vendors, and they may be created at a different time. You have legacy components that you may want to swap out yet. So in reality, you're dealing with a very heterogeneous kind of situation, which is continuously evolving, right? So therefore, you have to start from somewhere when you try to tackle the problem. Right. So therefore, at least we find that it's probably the best place to start with is from the cloud side, right? Which is where the data gets goes between the vehicle and the cloud, and being used by different application and services in the cloud. Right. So, and that's also where the user, especially the non-technical users, start interact with those data. Right. So by having VSS applied at that point, that allows us to at least present to the end users a consistent views of the data coming from different parts of a vehicle as well as different vehicles, right? And also allow us to basically, once we get data, right? John showed how we do that. But once we get the data from the vehicle, we can present it in a very consistent way to all kinds of applications and services downstream, either from the OEM themselves or from their partners, right? So therefore, we feel that's the best place to start, and that's we have implemented that already, right? But you also have to think, okay, then what's the next step, right? The next step is that if you think about vehicle side, nowadays there are a lot of vehicles that have something called like a gateway, right? Which is really the point where the data leaves the vehicle and gets to the cloud. So that's probably the next point that you can tackle, right? Where you have all this different kind of data that's coming together, but then if you can create a layer of translation there to make them look all consistent before they leave the vehicle, then that probably will help reduce the burden of your cloud. And also maybe if you have a multi-cloud environment, right? Or even you have some situation where you have your data coming from a vehicle but fed into a different part, depending on your service department or your R&D department, going to different endpoints, right? Then you don't have to duplicate the efforts in your cloud, and you have consistent data coming out of the vehicle. Yeah.
And to build on that 1 second, so I think that last point you made was a really good one. So as the data is leaving the vehicle, we're providing that abstraction in the cloud. A future direction for us and a future direction for the industry is to push both either natively from getting VSS adopted from the get-go, which hasn't necessarily been the case so far, a relatively new standard, but it's also something that we can also do with our solution using the gateway, so that we can provide, imagine in a V2V example or V2I example, even if not just going to the cloud, but V2V, we could potentially provide that translation, if you will, to translate from the native name to the VSS name during this kind of transition period when VSS isn't being done natively. Let's go to the next question. So the next question is from Stephen. Sebastian, I apologize. Is this primarily for data collection using VSS, or is there a planned capability to actuate, for example, open a trunk via VSS? Well, let me answer the broader question first, and then the engineers can get into the detail. So today we showed you two different solutions. One was the data collection, which was gathering data. The second one was vehicle automation. And I grant you, we didn't show you a demonstration, but in fact, the whole point of vehicle automation, it does cause actions. So for example, we're gathering data. For example, one of the examples we showed, just as a representative example, was imagine a configurable mode for new drivers. So the example we had is you have a 16-year-old, they just get their driver's license, and you say, okay, you can't drive with any passengers in the car, you can't go over a certain speed, you hand them the keys, they drive away, and the first thing they do is break all those rules. So one of the things we showed was it's very easy to deploy a mode where you can put in configurable limits. You can put in detection of, for example, are the passenger seatbelt buckled or the pressure sensor in the passenger seat showing occupants. And you could play alerts into the vehicle, or you could send notifications to the parents, or you can put in speed limiting, things like that. So the answer is very much so that the vehicle automation manager can provide actions. You gave an example of opening a trunk. We also showed examples using controlling the windshield wipers to do superior rain sensing and so on like that. So very much to take actions as well. Did you want to add anything to that, or did I?
No, I think you summed it pretty well.
Yes, that's absolutely right. That's absolutely right. And it's all about when the user has an intention, right, of doing something. How can you allow them to express that intention in the way that's most intuitive to them, right? You don't want them to specify, down to some very cryptic, physical name of a particular signal that will trigger a certain action in your vehicle. You don't want that, right? So definitely VSS is a way to make that much more intuitive to the end user who is actually trying to create this new functionality for the vehicle, right? And we definitely do that, right? But I think there's maybe even a further step from that in the near future, which is they can express that intention in some natural language way, and then we quickly translate that into VSS, right? And then deploy that to the vehicle, right? So that's probably another step forward.
Anyway, the idea of this automation is a much longer conversation for another time and not for the scope of today, but very much we are taking actions as well. Let's go on to the next question. So it's from Ki Hong, and I hope I'm not mispronouncing your name. Thank you for sharing. Just curious, how many OEMs are currently using COVESA VSS, and how's the traction been from OEMs? It might be a better question for the COVESA folks on the line as well, who might have a better sense of that.
Yeah, so there are a handful of OEMs who are using it. You can go on the wiki and see some of the OEMs that are using it are on this call, and the traction is going up for all the reasons that Sonatus has been saying. And so we're seeing a lot more interest in VSS, and I guess I would invite you guys to get involved, and you can see for yourself. Come to the meetings, and you can see. Does Sebastian or anyone on the call, do you have any comments on that? The people who are involved. Sound like someone was going to say something.
People are shy today. They don't want to speak up. I guess I would also ask a kind of a question, a pragmatic question from Sudhir, perhaps. We've been using this. We've been working with this directly. Have we found this easy to use? Have we found it intuitive? You deal with standards sometimes, and sometimes standards are cumbersome or complicated. What's been our experience in using VSS? What's been the...
So over the time, it has improved a lot, and definitely it's I wouldn't say it's pretty complex thing. So our journey was pretty smooth, ramping up and understanding and utilize the standards. Definitely, the starting place of having that catalog defined is a great starting example, which gives community and understanding of how the signal naming convention should be done, and having that template of, hey, these are the signals you can already use. Shows the power of the VSS, which can enable a lot more use cases. So from our point of view, it has been pretty smooth journey, and ramp up experience is pretty smooth.
I say, building on that, just to your last point is a really good one. That sometimes you find that standards can be kind of constraining, where you're limited or it's difficult to extend. And our experience, I think, and please correct me if I'm wrong, is that having this baseline standard of the recommended / off-the-shelf signal names that are there, plus the ability to extend them in a kind of a standards compliant way, provides the flexibility to extend the standard. Is that your experience as well?
That is correct. And with the VSS 3.0 versions, the overlay layers and extensibility helps us extend those capabilities, because not all vehicles, for example, even if you have standard naming convention, not all vehicles may have the features. Some are 2-seat passenger vehicles, some are 4, 5, 7. You can easily extend and adapt and tune to your own particular model, which is pretty powerful.
Yeah, I mean, because having this kind of intuitive common naming convention is a problem I think a lot of companies are facing, right? Like, we are thinking about this, 3, 4, 5 years ago when we just started, when we tried to, kind of architect our solutions and try to think about how we can make our solutions the most easiest for our users to use. And this is one of the problems we're trying to solve, right?
Yep.
And fortunately, we have VSS, which has already solved this problem for us, so that we don't have to reinvent the wheel. And even better, now it's an industry standard, and everybody else can follow, which allows us to have our tool to be able to interact with tools from other vendors very easily. So it's been great.
Yep.
Okay, great. I think the last we have is there kind of a rhetorical question from Sebastian saying, love to see more of you on the VSS calls, providing input and criticism of the things we've built and feedback. I would say probably we're a small company and we're quite busy, but nonetheless, I think we will absolutely do that, and I appreciate your comment. I think it's been important to us, and we want to continue to be involved. There was a follow-up question from Sebastian. Do you use VSS tools somewhere in your dev stack, or did we implement our own tools? Can you speak to that?
So we started with the catalog to, the data modeling, at least to use as a standard. We have our own custom tool in order to generate, and obviously we're evaluating some of the great tools that the VSS community provides. But so far we have our own dev stack tool that we have been using.
I mean, Nitesh asked a related question, which is, can you comment on the usability and extensibility of VSS tools in our info? It sounds like you've more or less answered that. I mean, it's not a criticism of existing tools, but we did our own.
Yeah, because we started early. It was called Geneva at the time, right? Not COVESA, and we started really early at the time. And as you, Fang, mentioned, we faced these problems early on when the company itself started. So we went with our own direction at the time.
Okay, very good. There's a follow-up from Kihong. One quick follow-up. My understanding is that VSS is open source, right? Question mark. Do OEMs need to join COVESA in order to use VSS tools? Maybe it might be good for one of the COVESA folks.
So it is open, and you don't have to be a member to use it. We encourage people to be members, and encourage everyone to get involved, as Sebastian was saying, but you don't have to. It's Mozilla public license, I think is what it is. And so basically, you can use it. And one of the key things about COVESA is we are open. You can actually come and join the meetings without being a member as well. Of course, we do want you to be a member, but it is open.
Very good. And from COVESA Mike, nice to see you. He was kind of commenting from what I'm hearing today. It sounds like VSS will make it easier for rapid prototyping and proof of concepts, and also multiple companies collaborating to build POCs. Well, I mean, my experience, and see if the team can jump in, is, I mean, some of that is what we're trying to facilitate. So it's a combination of VSS, yes, but also some of the solutions we're providing. For example, our automation manager, one of the things that a lot of our interested companies are looking at is the ability to do rapid prototyping and testing is very powerful, because you can prototype something in minutes and try it out and see how it goes. And then you might decide to implement it that way. You might decide to implement it using a heavyweight update. But that prototyping is really, really efficient. And then the second part of your question was about multiple companies collaborating together. I think you, Fang, mentioned earlier, as you have heterogeneous, for example, silicon or other components in a car, or in fact different tier ones in different generations, the consistency that VSS provides can provide a kind of a lubricating layer to make that all go more smoothly. You want to build on any of that?
Yeah, I think, that's a great example. And like V2X, which is V2V, V2I kind of use cases, if multiple companies collaborate and work together and enhance the, common standard catalog of data modeling, it's going to be super powerful in order to easily adopt and realize those benefits and use cases around V2X.
Fantastic. Any last question? Then we're getting to the end of time, and if not, we can wrap up.
I have one question. You may have touched on it a little bit, but what do you think VSS needs? Where is it lacking? Where would you go with it if you had, something available to you, or if you were to contribute? What would it be? Where should it go? What are we lacking?
Go ahead.
Okay, maybe I'll jump in and then feel free to help. So I think there are probably a couple of things that VSS can continue to evolve on. So one is to add some attributes that can really help, especially around data analytics. For example, time is a very important attribute for any piece of data. any kind of analysis will care a lot about when that particular piece of data is generated, right? So is there any way to make that attribute to be part of the standard itself so that we can easily apply that all around, right?
Time tag.
The time is a very important part, attribute of data beyond the data value itself. And the second is that right now we understand that VSS is focused on signals, right? But we also know any applications use a variety of data. Of course, signals are very important, but there are many other types of signals are also being used, like especially like in our software. We try to actually access pretty much all the data from the vehicle, right?
Yeah.
From your CAN network, from your Ethernet network, from different ECUs, and even we try to grab data from sometimes outside of the vehicle in order to facilitate certain functionality of our software. So expanding the scope of VSS, in the area that makes sense, I think it will further enhance the value of VSS, because the principle still applies for other type of data, right? Especially also like nowadays, EV is becoming a very important part, and there's a whole evolution going on around the battery subsystem and all that, right? So maybe also help enrich the VSS catalog or in that area. I think that could also help.
Okay, great. Let me answer this. There's a couple more questions that come in. Let me do the last one first. For Ty, he said he joined late. We are recording this. We will be publishing the recording, and so you'll be able to see the entirety of the meeting. So if you missed it, no trouble. So Ty, thank you for joining. Nitesh asked, can you comment on your experience with working on sample vehicle data set to experiment and quick start with developing downstream applications before you can get access to the data from an OEM? I guess I'm happy to say that we're working with an OEM directly, so for us that's not actually a problem, but I can recognize that that's a really valuable thing for other companies that would like to try it out. So my observation might be, and I don't know if this is something that, Paul, this has been done, if there's some sort of repository that can perhaps be provided from OEMs of some sample data sets that are VSS compliant, that could be quite useful. I'm happy to say we haven't had to do that. Sudhir, you know anything about that? Do you want to say, or is that pretty much the case?
No, I think that's pretty much the case.
But there is a question for Sudhir. The next one is from he says, well said about overlay. I can certainly see flexibility being brought in as compared to rigidity of standards. And here's the question. Do you see companies using overlays for this kind of rapid prototyping? Maybe it's a good question. Can you speak to that?
So definitely it's a direction. Obviously, adoption depends on each OEM. So we definitely would encourage the community and the OEMs to start leveraging that feature. But as John said earlier, for rapid prototyping, it's also some of the solution that the Sonatus provides in order to ease that rapid prototyping. Data modeling is definitely one important aspect, but there are a whole lot of other things which enable you to not having to write a whole lot of code, to focus on the business logic, and that's where like Vehicle Automation Manager, that solution Sonatus provides helps in.
Yeah, that's absolutely right. Yeah, so having a common naming convention across data is definitely very important, right. But you're still building some new functionalities, right? That's what you're trying to do, and that having the data is still not enough. You need to have the capabilities to quickly analyze that data, and based on the analysis results, to derive some actions that you can take so that you can create new functionality or new experience for the user. So for that, you do need additional solutions like what we're providing from our data collection as well as our automation manager.
Yep.
With that, I guess I want to thank everyone for the great engagement, and just by way of wrapping up, just want to say, as you perhaps made it clear from our conversations, we found VSS very useful. It's helped us provide consistency, and we're consistently using that in our cloud solution. And we're also pleased to be one of the leaders driving this adoption, one of the first to use it in production, and we're pleased about that. You can find more about us on our website, sonatus.com, or contact@sonatus.com, and we'd love to hear more about that, about your interest, and if you've been involved in the webinar, I'd love to chat with you further. We also talk a lot about these solutions consistently on our LinkedIn and our blogs on our website as well, so we'd love to hear from you. And then COVESA's information is on the right as well, covesa.global. And they're consistently putting out information like this, including some of the questions were about partner adoption and who's using this. And I think you can find more if you follow them there. Paul, any other things you want to mention about
Definitely. This is the first. I just want to emphasize this is the first in a series of these. So if you're in an organization that would like to present and bring your perspective, please let me know. Please get involved in VSS if you're using it or if you're interested in using it. You feel free to contact me. As Sebastian said, it'd be great to have you guys involved and beating it up. When you can. By that I mean the best possible way of beating it up. And Nitesh, I did want to say there is a group forming out of the University of Memphis that is making data available. We can follow up on that, and we would definitely like to do that because it has been a challenge because of IP and such. So just wanted to let you know that there is a group out of the University of Memphis that is doing this. If you know.
Perfect. Thanks,
them.
Paul. Is there a place? Do you have a link of that anywhere on the COVESA website that I can?
I'll make sure you get it.
Thank you.
Christos is the guy leading it. You may have met him at AMM or not, but so I'll definitely follow up there. So that's all I have to say. Any other questions?
Thanks very much. Glad to be able to participate.
Thank you very much.
Thank you all very much. Bye.
Thank you, everyone. Bye.
Bye.